In Industrial Automation Workshop Series, you are going to study another automation software, which is known as the Connected Component Workbench. We call it as a CCW. And in this workshop, you're going to learn how to use the software, how to create the project, and how to do a simple simulation. So instructions are here. So if you want to create a new project, you have to go to open the software, open the CCW software, go to new, and create a new project. You can name it and save it in wherever you want. Then you have to go to migrate 50 PLC. This is the only supported PLC for simulation. So all the other PLCs, you need to have a physical PLC, but migrate 50 series, 2880 LC50 and 48 QWB SIM. This is the only simulation PLC available in this software. So you have to select this right one and then add to the project. Then you can create a new ladder diagram. So in this workshop, you are asked to solve a simple problem using a counter. If I explain the problem, in a car parking system, so there are some cars enter into the car parking and some cars that can leave. So there's a sensor to count the cars that enters to the car park and another counter sensor to count the number of vehicles leaving. So there should be a light indicator, a vacancy light. It should be illuminated until 10 cars occupy the parking space. So which means like you should display the vacancy light until 10 cars occupy the parking lot. So once 10 cars are filled, a full light should be illuminated so that the people knows that the car park is full and there are 10 cars. So there's no point of entering to the car park. So in your program, there should be a start button to enable the system and a reset button to reset or deactivate the system. So you have to use for the simulation momentary push buttons to simulate entering and leaving vehicles. First, you need to identify number of inputs and outputs to implement the systems. Basically, we have a start button and reset button and a momentary push button for simulate the cars that enter to the car park and another momentary push button that can simulate cars that leave the parking lot. Then you have to design the ladder diagram and then build it and enable the simulator and power on the simulator and then download it to the simulator and open the correct device through the Ethernet, then download with project values. So as you should remember, like this is an open source simulation software. It only allows you to simulate it until 10 minutes. Once you download, you can run the system up to 10 minutes. CCW software, you have to first create a project and name the project and save it in a place in your local computer. Then go to controller and select migrate 50 and select this simulation type PLC. After adding it to the project, you have to create a new ladder diagram. Select that new ladder diagram and go to global variables, and you have, based on your input output assignment, you have to, there are multiple inputs and outputs. So here you have to label your outputs and inputs in the global variable list, which are directly linked to your inputs and outputs of the PLC. In this case, it is the simulation PLC. So we can label the digital input 00 to start, momentary push button, and 0, 1 to reset, and 0, 2 to count up, and 0, 3, 4 count down. So those are basically 4 inputs. And now we can assign the digital outputs from T out. So we have two lamps. First one is a vacancy lamp. The second one is the full lamp. So they are the light indicators depending on the number of vehicles. Now you can create your ladder diagram at multiple networks depending on your requirement. So we can first assign the start momentary push button to a normally open contact. Then you can add the parallel contact to latch when you press this start button. And as you know, we can assign it to a coil, that is start logic coil. So that is a variable which is not linked to a output, but it is a local variable. And we assign, so that is your first network to start and reset. Now we have to select a up-down counter from this list. So we select CTUT, and for counting up, you have to assign the C up in your digital input. For countdown, you can assign C down. For reset, you have to select the reset input, and preset value is 10 because we are measuring up to 10. Now the counter output should be assigned to another variable. That could be another local variable. You have to name the local variable as your preferred name. Once you assign it to a local variable, so the counter output is now connected to a coil. Then we can assign our lamps. So first, as you know, like the start logic is the enable of the system, and for the vacancy and full lamps, we can add normally open and normally close contacts. So until the count to 10, so it is vacancy. So we have to add the vacancy lamp for the third rung. So which means any value lower than 10, the vacancy lamp will lit. And the counter output, once 10 vehicles are counted, it is the full lamp. Now we can build the project. So if there aren't any compilation errors, you are all good to go. Then select the simulator, because we are running a simulator, and turn the power on. Remember the IP address of in the simulator. Now you have to download this file to your simulator. Go to Ethernet settings and select the IP address which is assigned to your simulator. Now you are running the simulator, so you have to download with your project values. So the download is completed now. So you have to select it yes, and then OK. So now you can visualize your ladder diagram as well as the simulation window. This is the PLC front view. So you have the inputs and outputs. So the top is the inputs and the bottom is the outputs. So when you press the 0, that is start the your system, and the vacancy lamp should lit. So 0, 1, and 0, 3 are assigned for counter down and reset. 0, 2 is for up counting. So we have count up to 3 now. So C3 is down count. So we have set, now we can count it down, and you press C input 2. We can now see the count is counting up to 10. Once it is counting up to 10, the full lamp will lit. So we can reset or system, or you can play it down the counter. So if you want to reset the system, you have to press 0, 1, digital input 0, 1. So that will reset your system. So now you can disconnect from the simulation. So that is basically all about this simulation.